Feel free to grab a coffee at any time, because as you can see, I do talk a lot. I want to try and get through as much as I can tonight to make the bookwork and the theory side of things as easy as possible. So, if I leave a full thickness weld there plus reinforcement, I can well have stress-related problems, flexing problems. So you look at truck chassis and all sorts of things. If it's going to break, usually it breaks next to the weld, more so than the weld itself, because usually the weld's got plenty of strength, but it's the change in section that's a problem. So if you're going to have flexing problems, you're going to get a sand and you're going to dress that off to make it as a continuous profile as possible. So you need full thickness welds. So if you just butt them together and put a weld on the top, you can't grind it off, there's hardly anything left. So they're things that you need to consider. So if you don't fit your joints together properly, you've got problems. So you look at, say, double V butt. Let's go for a bit of a lap at that sort of an issue. So we're talking about butt welds, and I've got a heavier piece of material. I can't, let's say I'm welding 10 mil and I'm stick welding, and I stick weld, that's probably as good as I'm going to get. Okay, I use a bigger rod and I burn in a lot more and I get that much. I can't get out the other side if it's closed. If I open it up and try, it's still not really going to work. I'm going to have to open it a long way. I'm trying to get melting going on down the bottom there. And it's just not going to happen with an open gap. You get it open enough to get down the bottom, there's nothing to hit. You know, the welding metal's got nothing to hit. So how am I going to deal with that? What I do is I V it out. So I leave a little bit of gap. So what you call it, that's called root gap, and that's root face. And I balance that gap and face to control the penetration. So my electrode, I can get right down in there, and I can get that weld to happen, so the root run as it's called. Proper penetration, 10% just coming through the other side. Now then I can start filling up however many passes it needs to be according to the size of the weld. So I've got full thickness weld which I can safely grind off on the top, grind off on the bottom, and it's continuous and no stress razor. Let's say I go a little bit thicker. So now let's say that was 10 mil. 12 mil, now I've gone to 25 mil plate. If I V that out, I've got a huge amount of weld in there. And if I've got a huge amount of weld like that, I've also got a huge amount of distortion. That's a real problem. I don't want that huge amount of distortion. But I want a full thickness weld. So what am I going to do? I'm going to V it out from that side and that side. Now if you sort of looked at it, you would be doing, so you'd be doing that much weld and that much weld and this much weld you're saving, you're not doing any of that. So I'm putting a lot less weld metal in to get the same full thickness weld, the same strength, everything just as good. If I'm putting down less weld, I'm doing a lot less heat input, I'm balancing the distortion, everything's going really good for me. So, as we discussed, you'll do one weld that does the root, and then you'll start filling up in a balanced sort of fashion. Hello. Yeah, just leave it and I'll do both of them. Well, I'd alarm that, say to me, because I'm going to really struggle to do it. So just 1 and 2 left on, I'd say. Thanks. Let's see how big a muck I can make the alarms tonight. So, a V can become a problem. So let's say I go even thicker just to exaggerate it. So I'm V'ing that out. I've still got a huge weld there. I've still got a huge width there. And let's say my electrode's that big. I don't need a big V like that. I don't need to put that volume of metal in. All I need to do is be able to get into the bottom there. So what I'm going to do is modify it. So let's say it's on a single thickness. I can only get through to one side. I'm going to do something like that. A little gap in there. So I can still get my electrode in there, no problem. But there is a lot less. If I had a V, not quite drawn accurately, I've got all this extra weld that I don't have to do. Why put back that metal? Why do the work of removing it and then do the work again and putting it all back in again? I only need to get access, so I do a U-joint. Then if I go to thicker material, same sort of an issue, why don't I do a double U-joint? I just need enough opening to be sure I can get in the bottom and weld the bottom properly, get good fusion, and then work my way out again. So we adjust the joints to suit the situation. So that's what some of those are looking at. So a single U butt, a double V butt, single V butt, and so on. Different joints to solve different problems. So we're looking one at a time, not the greatest pictures, but that's what I came up with last night. Closed butt joint, open butt joint. So as the material thickness goes up, you may just be able to open the joint and get penetration. Once you get a little bit thicker, then that's not going to work anymore. So corners, got to be set up properly in the first place. You may even want to leave a little gap between them if you want to control penetration, depends on circumstances. So a fillet weld, so that's a T-joint. That's a fairly common thing. Trying to get the leg lengths the same, so some of the terminology. So that's a leg length, and the leg length, you want the same amount of metal on both plates. So that's a bit of a steering issue. You can have it, I used to do a demo. Let's say I've got a T-joint and something's in the road and I can't get the proper electrode angle or mid-gun angle that I want. I can still get a proper fillet weld that's equal on both sides, anywhere from the rod laying flat to the rod standing vertical, just by adjusting where the point of the arc's coming off the end of the rod is. And that's an interesting thing. You want to perhaps get some scrap and just play around with things like that. There's a fillet that normally you just get an even angle and just go along. Well, let's try it laying over. So I just need to steer it down, make it arc in the right sort of spot, weld along, and then just rotate up and have your thing vertical, and then stop and have a look at it. You should be able to get a mitre fillet all the way along. So these are things that can happen. You can direct your weld metal almost like spraying paint. It's directional. You can steer it. You've got a heavy piece and a thin piece. You'll steer your heat to the thick piece and preserve the thin piece. You don't want to steer all the heat on the thin piece, it'll blow away on you. So a lap joint, not that common really. Laps just don't seem to be a thing we do anymore. We used to do them a lot with boilers and rivet them, but we don't tend to do that. You tend to be butt welding more these days. So. But in effect it's a fillet joint. It's just that the vertical member's not very thick. Talked earlier about a joint you may make that doesn't require filler rod. Any reasons you can think of why I'd like to set a joint up that I don't actually add filler rod? What would be something that would be a plus for that? Why would I bother bending the edges over and then just fusing them together?
Contamination?
So cost could be it.
Contamination, like storage of some sort of chemical.
There might be a reason there. It's not one that popped into my head. Let's say I'm welding titanium. So I've got my titanium sheet that I'm making it out of. What filler rod am I going to use?
Titanium?
Yeah. And if I can't get any and I don't know the grade that I'm welding and so on, I'm going to know that I'm going to get a good joint if I use the material to be its own filler rod. So I just fold a little bit up and it's got to be the same material. It's got to be happy to weld to itself because it's the right thing. I don't have to know, was it this grade or that grade, and stainless, some of the exotic stainless is a little bit like that.
You trim a little bit off, mate, you know.
Yeah, and that's what I was going to say is if you've got a guillotine, you might put your sheet in and just shave a little piece off to get a piece of filler rod that you know is the same composition as your base metal. And then you don't get any issues with incompatibility between the two. So rarely will you see that one, but it's probably underutilised. There's one I still haven't finished. There's a few more examples, pretty much the same as we've already talked about. Edge preparation, so thin sheets, you're probably not going to do anything with it. Once you start getting a bit thicker, you're probably going to grind it off, plasma cut it off, oxy it off or whatever. Start getting thicker material again, you're almost definitely going to be oxying it off. You might mill it off. We used to prepare plates for the DLI tickets in a shaper, shape them off, do a heap of plates in one pass. W, so a single bevel butt, so you might be butting a piece of pipe up to another piece of pipe or whatever. You can only prepare one. Where you've got uneven sections, you tend to prep them so that you get an even flow of stresses.